weekly, plotted against the Regents exam grades, which are the Y values here. And looking at this graph, we are going to answer these questions. So try to answer them before I uncover the answer. Let's see if your answer coincides with mine. Describe a possible relationship between these two variables. Well, what do you think? The more it looks as if, according to this data, the more hours spent in the park, the lower the Regents exam grade is. Part B, predict the Regents grade of someone who spends 11 hours a week in the park. Well, according to this data, it looks as if 11 hours will be somewhere here. So somewhere between 0 and 10. Right, so it's got to be, so for after 10 hours of staying in the park, the Regents grade is at 10. So if they spend more hours in the park, it's going to go even lower than 10, but it can't go below 0. So that's why I said between 0 and 10. So notice for this data, as X is increasing, what is the Y doing? What are the Y values? What's happening to the Y values? They are decreasing. Okay. So in this case, what we're calling this kind of correlation is a negative correlation. So think of it as a negative slope. If you were to draw a line that represents this data, it would have a negative slope because as X increases, Y decreases. So this is called a negative correlation. Okay. Now here's another example. Typo here. The number of college years, let's cross this out, is on the x-axis. Ooh, naked graph, Miss Bono. Oh, Miss Bono. Plotted against the salaries in tens of thousands on the y-axis. Describe a possible relationship between these two variables. Well, we're noticing that as X gets larger, what happens to the Y values? No, the more years someone spends in college, the higher their salary will be, according to this data. Part B, predict the salary of someone who has 9 years of college education. Well, this graph only goes up to 8 years, but if we were to guess according to this data, we could guess that it might be above 70,000. That would be a guess, because after 8 years of college, you would make 70,000. So if you go one more year, you probably would make more. So in this case, as X increases, Y also increases. And can you guess what kind of correlation this is? Remember, the previous one was a negative correlation. The Y values decreased as X increased. Here, the Y values are increasing as Y is increasing. So this is called a positive correlation. Okay, if both variables are decreasing or both variables are increasing, it's called a positive correlation. Number 3. Well, this scatter plot looks odd, doesn't it? It has no pattern whatsoever. So is there a relationship between these variables here, the heights of trees and their diameter? Nope. And the reason for that is that the graph is random. It has no pattern whatsoever. So we cannot predict anything based on this data. And if there is no pattern to the scatter plot, there is no correlation between the variables. So no predictions can be made. We're ready now to talk about the correlation coefficient. Do you understand what correlation means? It's a relationship that allows you to predict one variable based on the other. A correlation coefficient is a number, kind of like a slope is a number. So correlation coefficient is a number. It's called R, and it calculates how close to a line a set of data is. And this R is a number between -1 and 1, inclusive. It can be outside of this range. If R is less than 0, meaning a negative number, the data has a negative correlation. If R is bigger than 0, means the data has a positive correlation. And the closer R is to the extremes, the 1 or -1, the closer the data is to a line. Basically, if the graph has a negative slope, the correlation is negative. If it has positive slope, the correlation is positive. So let's go back here for a second. Here, the correlation coefficient would be a negative number because we have negative correlation. Here, it would be a positive number because we have a positive correlation. And here it would be very close to 0 because there is no correlation. Okay? So that's what R means. Now, what I'd like to do is get your calculator ready. I would like to help you figure out how to find the correlation coefficient on the calculator because doing it by hand requires an advanced formula that is not part of this course. So the only way to get this is with a calculator. Okay, so plot these data in your calculator. So remember on the T83, you would go to, first you have to turn on diagnostic on for this. For the T83 and 84 only, turn diagnostic on before you continue. For that, you have to press second 0 diagnostic on. I'll show you in a second. If this would turn on, that would be wonderful. Come on, buddy. There you go. All right, so I'm going to go to the catalog. So press second 0. And I want to go to diagnostic on. This is alphabetical. So if you want to go to D more quickly, instead of scrolling down, you can press alpha D. Alpha D. There we go. And we need to go down to diagnostic on. And this would allow you to see the correlation coefficient being calculated. If diagnostic is off, then you won't see it. So you're not going to see anything now. It's just going to say done, but you're going to see what it is in a minute. I already put in this data in my list. So stat, edit, there are your lists. So I have this data in L1 and L2. I also have data in L3 and L4, but don't worry about that. That's for later. So you're putting your data here in L1 and L2. Okay. Now on the other calculator, you have to go to menu. I'm sorry, you have to go to on, and you go to your list and spreadsheets. And my data is, darn, I don't have it. Okay, I'll have to put it in here. Give me a second. So for this calculator, the Inspire, you go to your list and spreadsheets and you put your data in here. Don't forget to label the first column X, the second column Y, and put in all your numbers. So annoying. So the numbers are here. Okay. Now to get to the scatter plot from here, we go back to the main screen here, the home screen, and click data and statistics, and you have to tell it which one the X value is. That's the X. Go to here, this is the Y, and then there's your scatter plot. Okay. Now for the other calculator, to get to the scatter plot, you go to second Y equals. Now our data is in L1 and L2, and my plot is on, the scatter plot is highlighted, but I have L3 and L4 here, so I'm going to put L1 in here and L2, second L2. You probably have it fine. Also, don't forget here you have to create the proper zoom. So for stat, it's going to be zoom 9. If you don't do that, you might not see all of the data. Okay, so that's what it would look like. Disregard this here. So remember what I told you before you do any statistical graphing, you should just clear everything in your Y equal menu. So I was working on something earlier and I left it in here. Okay, so the plots look the same. So yeah, that's how you do it. So here are our plots with both calculators. Okay. So now to find the linear regression, if you remember, with the old calculator, the 83, 84, you go to, well, I think we get out of here. So second mode to quit it. Go to stat, and you have to calculate. So we go over to calc, and we're calculating the linear regression, which is choice 4. There you go. Now, this one again might be slightly different from the T83. L1 and L2. Now, for the other one, if I'll show you in a second, but you need to store your data in Y1, and the way you get that is vars, yvars. So you move over to the right function and Y1. Okay, and then you click calculate. Okay. In the other calculator, you have to put the Y1 after you see lin reg. So there you go. Okay, so that's what you would see. So there's your equation. It's y equal to ax plus b, where a and b are these numbers. Now for the other calculator, to get the regression line, we go back to the home screen, and we go to, no, I think you could do it straight from here, actually. Yeah, we could do it straight from here. If we just go to menu, one second. Okay. Oh, wait, 1 second. This is not the graph that I wanted. This is the graph. This is the graph with the X and the Y, right? So if you go to menu and analyze, regression, MX plus B, and there you have it. So it's exactly the same. Just be careful. You see this little negative here? You almost can't see it. It's so tiny. Okay, so that's what you should be getting. And that's what it would look like in this calculator. Now, obviously, on the Regents, if you have the old calculator, you cannot leave it like this. This is calculator lingo. You have to rewrite this as y equals ax plus b, but replace a with this number and b with this number. Okay, so it would look like that. And you can simplify the plus or minus to just a minus, because adding a negative is equivalent to subtracting. Also, you have to pay attention sometimes on the Regents. They'll ask you to round to the nearest thousandth or nearest hundredth, so you have to do that. Okay. And we're going to find the correlation coefficient in a minute. But next, we're going to use this regression equation to predict the hours, the hourly tips for someone working 35 hours. So if you go back to this table, what these values are saying is these are the numbers of hours worked, and these are the tips for someone. So if they work 19 hours, they make $10 in tips. They worked 25 hours, they made $8.50. Must not have been a good day. But according to this data, if they worked 35 hours, now remember, this is your X, right? And this is your Y. So the number of hours they worked is X. So if they work 35 hours, that means that my X now is 35. I'm replacing my X at 35, and I'm predicting the hourly tips. I'm predicting, so this is my Y here. I'm predicting what is Y when X is 35. So I put that in the calculator, and I get $14.33. Right? So what I just did, I used this equation, I replaced X with 35, and I found Y. And the way I did this, I just put it in the calculator. Okay. Describe the correlation and find the correlation coefficient. Well, just by looking at the scatter plot, it looks like the correlation is positive because the points are going up as you're going As X increases, Y increases. So it's a positive correlation. Now the correlation coefficient, remember that number that we were talking about before? There it is. It's your R. It's 0.802, blah, blah, blah. That's it. Now with the other calculator, what you do is, let's see, I think we need to go back to the spreadsheet here. And you go to menu, statistics, stat calculations, linear regression. Yeah, I've had trouble with this before. Let's do this again. Probably on your calculator, you won't have this trouble that I'm having here with my, okay. Or perhaps, I think maybe it's my mistake. I have to highlight one of the column headings. Let's try it again. Statistics, stat calculations, MX plus B. Maybe that was it. My X list, I called X. My Y list, I called Y. I could save the equation in F2, and I'll show you what that means in a minute. So click OK. And it's giving me this whole bunch of stuff, but I'm really just looking for the correlation coefficient, which remember is R. So here's my R. It's pretty close to 1, so that tells me that the line is a pretty good fit for this information, for this scatter plot. So there's a positive correlation since as X increases, Y increases, and R is about 0.802, which is close to 1. So the data is well approximated by the regression line. Next, let's see, how much do we have? We have a couple more. We're almost done. Okay. Number 5, enter the data in the calculator. So here's your, so it's basically just another practice problem, but the outcome is going to be slightly different. So here's, in this problem, what the person's looking to see is if there's any correlation between how anxious people are on a level of 1 to 5, and if that has any impact on their quiz score. So that's the data they collected. Now, of course, in reality, there are thousands upon thousands of data points when you do a statistical study. But obviously, for the purposes of teaching, we have to use very few. So you enter the data on your calculator, which you know how to. And here's a scatter plot and the regression equation. That's what it would look like. Okay. And it's 2.6. Y equal to 2.6. Because there was no correlation here. These points are random. But you can find R. So if the line cannot predict this, because there's no pattern, then R should be very close to 0. And if you do it right, then your R would be equal to 0 exactly in this particular case. So in this study, they found that there's no relationship between anxiety and quiz score. It's hard to believe, but this is the example. Okay, and in number 6, it's been shown that the shoe size is highly correlated to reading level. In other words, the bigger your shoe size, the higher your reading level. Do you believe that large shoe size causes people to be better readers? True or false? Does correlation imply causation? So just because two variables are correlated, that means one can be predicted from the other. Does that imply that one causes the other to happen? And the answer to that, of course, is no. And through the examples that we're going to talk about here, you'll see. So here's an example of two variables that are highly correlated in which one causes the other to change. So there's causation. The number of hours you work and the amount of money you make. They are definitely correlated, and there's causation here because the more hours you work, the more money you're going to make. So the number of hours causes you to make more money. There's a direct causation there. Here's an example of two variables that are correlated, but there's no causation. The number of potholes in winter and the number of ice cream sales in winter. right? So the number of potholes in winter go up, and the number of ice cream sales in winter go down. So if you analyze these, as these go up, these go down. But does one cause the other to change? No, they're both caused by the cold weather. They're not caused by each other. So the same thing with the shoe size. The reason that someone with a bigger shoe size has a higher reading level is simply because they're older. One does not have anything to do with the other, but you can predict reading level by shoe size in most cases. So that's it. Bye.